Hi class, welcome to lesson 35. In this lesson, we will work to determine how to calculate the gram formula mass of a substance. Recall that a substance is either an element or a compound. In order to calculate the gram formula mass of a substance, it is important you remember how to interpret chemical formulas. The first part of a chemical formula we will discuss are subscripts. Subscripts are the lowered numbers that go behind an atom. In this example, we have 2 hydrogen and only 1 sulfur. If no numeric subscript is given, it is understood to be 1. Coefficients are used in chemical formulas to signify the number of those formula units. Coefficients are large numbers placed in front of the formula. In this example, 2 dihydrogen monosulfides would have 4 hydrogens and 2 sulfurs. In some formulas, you may encounter parentheses. Parentheses are used particularly for polyatomic ions found on table E. In this formula for barium hydroxide, we can see that the subscript 2 is outside of the parentheses. When you have parentheses, the subscript outside applies to all of the elements within. So barium hydroxide has 1 barium, 2 oxygens, and 2 hydrogens. Now that we've talked about how to read a chemical formula, let's talk about the compound aluminum fluoride. Aluminum is a metal and fluorine is a nonmetal. When they make a stable ionic compound, their total charge is 0. So there is 1 aluminum ion and 3 fluorine ions. To calculate the gram formula mass, we will need to use our reference table. Our reference table gives the average atomic mass, or the average mass of every naturally occurring isotope for each element. The average atomic mass is given to varying numbers of significant digits. To calculate gram formula mass, it is okay to round to the 10th place. Make sure you are rounding and not truncating numbers. So aluminum's mass rounds to 27.0 grams. And fluorine's mass rounds to 19.0 grams. Notice for fluorine, although it says 18.99, we do not truncate the number, but instead we round. Since we have 1 aluminum but 3 fluorines, we're going to have to multiply the 19 times 3. This is where you'll require your scientific non-graphing calculator. On your next exit ticket, 1 point can be earned from coming to class prepared with a proper calculator. So when we use our calculator to carry out the multiplication, we see that 3 times 19 is 57. If we add that mass to the mass of our single aluminum, 27, we can get the total mass of our substance to be 84. Now, because we had a decimal point in our masses, we will keep it. Now, when we report an answer for gram formula mass, we can either use the units atomic mass units, a derived unit where a proton is 1, a neutron weighs 1, and an electron weighs nothing. Or you can report the same number with the units of grams per mole. A gram is a unit of measurement we use in the lab, and a mole is the quantity of particles that you will need to have exactly a measurable number, in this case 84 grams of the substance. We'll talk about moles later. Let's look at this next example. This is a polyatomic ion. It is not binary. You can see that there are 3 different elements. Using reference table E, this is called sodium sulfate. In 1 unit of sodium sulfate, we have 2 sodium atoms, and we have 1 sulfate ion. A sulfate ion is a sulfur atom and 4 oxygen atoms. We can use this information to calculate gram formula mass for sodium sulfate. So here, to calculate sodium sulfate, we can see that we have 2 sodium atoms, 1 sulfur atom, because when there is no subscript provided, it is understood to be a subscript of 1, and 4 oxygen atoms. When we carefully look at our reference table, we can see that the gram formula mass of sodium is 23. The formula mass of sulfur, which is recorded to 32.06, rounds to 32.1 when rounding to the 10th place. And oxygen's mass of 15.9994 rounds to 16.0 to the 10th place. When we take these numbers and add them together, we get a final mass of 132.1. Now we're ready for our final example. This is calcium nitrate. One clue that we have a polyatomic ion found on reference table E are the presence of parentheses. So in this formula, we have 1 calcium atom and 2 -1 charged nitrate ions. Nitrate has 1 nitrogen and 3 oxygens, but since we have a 2 outside of the parentheses, we need to make sure that we have 2 nitrates. So here we have the elements calcium, nitrogen, and oxygen. There is 1 calcium. When we distribute this 2, there are 2 nitrogens and there are 6 oxygens. If you look closely on your reference table, you can find that the mass of calcium is reported to be 40.08. When we round to the 10th place, the mass of calcium averages to 40.1. Nitrogen averages to 0.0, and oxygen averages to 16.0. Once we take these numbers, we can place them into our calculator to find the total. You can see that the gram formula mass of calcium nitrate is 164.1. We may report our answer in either atomic mass units or grams per mole. This concludes Lesson 35. Make sure you complete your homework in Google Classroom and bring any questions you still have to class. See you soon.